we've got to have those negative charges, so he says those negative charges are just kind of rotating around the nucleus. So let's fill in the blanks here for Rutherford. So, we know the first one, he performed the gold foil experiment to discover the nucleus. Number 2, he inferred that the positive charge was clustered in a tiny region in the center. He called this tiny region the nucleus. So remember, based on the way that those particles bounced off of the atoms, he was able to figure out and able to infer that the positive charges were found in the middle. It wasn't that the positive charges were like the whole thing with negative charges scattered throughout. The positive charges were in the middle. Okay, and he called that middle area the nucleus. Okay. So Rutherford named the positive particles in the nucleus protons. Now, I think this is a typo here because it just says the blank. So you can scribble that out. Sorry about that. All right. What we have next, Bohr. And it's not because he's boring. That's because that's his name. All right. So we have Mr. Bohr here. And Mr. Bohr took Rutherford's atom, and he kind of was focused a little bit on these electrons. That really was his goal, was looking at these little yellow electrons which had their negative charge. And what he figured out is that these electrons, some of them have more energy than others. And so the way that he put it was that the electrons that had less energy were closer to this nucleus, this positively charged nucleus that Rutherford inferred and discovered. And that higher charged energy, higher energy electrons were around the outside. So, that's what we have here. He kind of put things into energy levels. He said, all right, you've got low amount of energy, you got medium amount of energy, high amount of energy, and it just kind of goes up like that. So he has these different energy levels. So let's go through the blanks for Mr. Bohr. Bohr found that electrons could have only specific amounts of energy which caused them to move in orbits. Found that electrons could have only specific amounts of energy which caused them to move in orbits. Now, probably the only time you've heard the word orbits is, I'm not talking about the car company either. Orbiting is what happens with the planets going around the sun. Like if this was the sun, oh look, here's Earth, orbiting the sun. So he compared it to that. So we've got these little electrons orbiting our nucleus, and depending on how far away they are, tells us how much energy they have. Okay, moving on. The next one that we have here, and you're going to have to bear with me for not being a magnificent artist and having trouble showing our cloud model. Our next one is a cloud model, and basically what happened in the cloud model is a move a little bit away from saying that the electrons are all in these orbits. The cloud of electrons model tells us that these electrons are moving so fast we cannot even predict where they are because they are moving so fast. We can have like a general idea where they are, and that's why I tried to draw it a little bit darker towards the center, because it's more likely that electrons are a little bit closer to the center, and it's less likely for them to be further away from the center. So the cloud model is kind of like a fan. Here is a fan. You can see all of the blades on the fan. There are 1, 2, 3, 4, 5. I turn the fan on. How many blades do you see now? So anyways, you can't count them when the blades are moving so fast. Just like how these electrons, when they're moving so fast, we can't predict where one of them is. So we just kind of have these generalizations saying, all right, it's probably pretty close to this nucleus here, and some of them might be a little further away. So that's why it's illustrated as a cloud. That's why when you look at it at your book, it's a little bit darker towards the nucleus and it gets lighter as you come out. But what you see here in this cloud, we have those electrons. So we have those negative charges. And I don't know if you've been noticing, but for every single one of these pictures, there's an equal amount of negatives and an equal amount of positives. So, cloud of electrons. Number one. Electrons don't orbit like planets, but rather in a cloud-like region around the nucleus. Electrons don't orbit like planets, but rather in a cloud-like region around the nucleus. Now, we still have to take into account all the research that Bohr did to say, hey, there's all these different energy levels. So we still have to include these energy levels in our cloud of electrons models. So, electrons with the same amount of energy are found orbiting the nucleus in what are called energy levels. So, it gets kind of complex. I don't really want to get too much into it, but different electrons kind of orbit at different distances still, but they're not necessarily orbiting, they're just going around so fast in this cloud here. All right, the last one is very, very similar to the cloud model. It is just that we have finally found the last piece of our atomic subparticles. The neutron was the last particle to get discovered, and you'll notice if you think back to all of these, we don't have any neutrons. So the modern atomic model brings the neutron to us. This guy named James Chadwick discovered the neutron in the nucleus. So there's your first blank, the neutron in the nucleus. And so, I know I am not the greatest artist ever, but what we've got here, we've got the blue guys are representing the neutrons. And the pink guys have been representing the protons, or the positive charges, the whole time. So we've got them all clumped here in our nucleus, and then again we've got our beautiful little cloud. So we haven't changed anything about electrons in this model. The only thing we have changed from the cloud model is that now we've got the neutrons. So let's fill in the blanks, and then you guys can be done. So we've already done number one. Number two. The neutron was hard to detect because it has a neutral charge. A neutral charge just basically means that it's not positive and it's not negative. It's a whole lot easier to find something if it's got a charge. However, if it's something that you still can't see and it doesn't have a charge, it's it just makes it really, really hard to detect. So that's why it took so long. It wasn't until the 1930s or so that they discovered this. Okay, last one. Atoms as a whole have a neutral charge because there are an equal amount of protons and electrons. Repeat that. Atoms as a whole have a neutral charge because there are an equal amount of protons and electrons. Remember, protons are positive, electrons are negative, neutrons are neutral, so that's the way it goes. So hopefully you understand a little bit more about what all the things around you are made up of. And hopefully you've got a better idea and a better picture in your mind of what we mean when we say an atom. So what you're going to be doing now, you're going to use these notes. You're going to make sure that you've got a textbook, and you're going to need to do the homework worksheet that I have for you to do. After you've done that, you can either go to the more information page on this website, or you can read a book silently, or if you have missing work in science, you can also work on that. So hopefully this was helpful, and that's it. Have a good day.